Welcome to everyone who is joining us today. Today's session is being driven out of the Reactor London and will be on Succeed Your DevOps Investment. So you're very welcome today. Today's session will run over the next about 60 minutes, and that's inclusive of any Q&A that you have. So whilst you are on mute today, please do feel free to get involved in the chat. If you have a question towards the end, there is a raise your hand feature within Teams, so you're also welcome to use that too. But for any conversation or questions, we definitely welcome you to use the chat function as much as you like. So just to quickly run over our code of conduct before we get started today. So this is just a reminder to everyone who's joining us to be aware of one another, welcoming and respectful throughout, and just understanding of any differences that we might see throughout the chat and any Q&A that we have as well. Just a reminder to anyone who's joining us now, this session is being recorded and it will be made available to watch on demand. That will go live on the Microsoft Reactor YouTube channel, usually within a couple of days. So I'll post a link into the chat during the session as well, so you have that handy too. So our speaker today is Lars Hall. We're delighted to have him with us. Lars is joining us from Stratitech and is an architect with Stratitech. Bringing a wealth of experience with him, has been working over the last 20 years in the IT industry. So we're really excited, Lars, for your session today. So without further ado, Lars, I'll hand over to you and stop sharing my screen.
Thanks, Emma. I start to try to share my screen here. I hope bandwidth is okay. What happened now? I tried to. Okay. Now we start. Okay, welcome everyone. I will try as best as I can to explain how I actually managed to get DevOps working in different organizations. I tried this the first time in the beginning of 2000, just after millennium, and it was not the same in those days as it is now. My background is I started in the dark ages. I started my first company in 1985, and then I started a new company in 89, and then I sold that company and went out to become a consultant. And then I met some other people, and we started another company. And after that, I worked at an e-commerce company, and then I went to Click. And then I worked at Mercedes R&D in Stuttgart, and then I went back and worked in Denmark as a consultant, and then I worked at Axiel, who's building software for collections and the library system. And then I started to join Stratitech in the beginning of this year. So that's my little journey. And in the last 15 years, a hot topic has been about the DevOps part. But it was obvious that many organizations pushed it too hard and didn't realize what it actually meant and what it would actually cost, and they didn't look at the benefits. So just to be sure, I don't expect anyone is a DevOps guru in this little session, so I will talk about the fundamentals about DevOps, and then I will focus on how I have succeeded in implementing DevOps. And if there are any questions, I try to answer them. And this is the first part of the session. The second part of the session, I will show with a tool how you can actually build pipelines and actually generate builds and write in C# code. And I have built a little project with a .NET Core web API. And I will talk about what I've done with that and how I get it going up in Azure DevOps. So hopefully it will be a little bit more fun to see that compared to listening to the first part, but the first part is crucial because for me it's a summary of how I approach when you introduce DevOps in an organization. So the first thing about fundamentals is pipeline and pipeline stages. And if you look at pipelines, pipeline is nothing more than an automated chain of tasks from the beginning where a user commits code, the code is merged with the main branch or another branch, a build is generated, unit tests and test coverage tests are running, and then the developer decide, okay, I think I will publish this code. So they do a code review and maybe they discover some issues, and then the code is finally deployed in some stage. A stage could be dev, test, pre-prod, or production. But we will come into this pause in a few minutes here. So if we look at pipeline stages, we have the first part, which is continuous integration. It's when the code is done, the unit test has been running, and the build has been generated and finally deployed in some little area or stage. Then you have continuous delivery, and that means that the whole chain of tasks is automated from code completion until the last stage. Maybe it's called pre-prod. Everything has been validated and is ready to go into production, but that step is manual, and most companies choose to run it as continuous delivery. But when I worked at the e-commerce company, we finally succeeded in reaching continuous deployment, and that meant when the review was done with the code and all the tests has passed in the different stages, it was automatically deployed out in production. And I don't see many R&D that actually do the continuous deployment. Most R&Ds that I worked, they stop at the continuous delivery. So these are the pipeline stages: continuous integration, continuous delivery, and continuous deployment. It was just some basics about it. And when you implement DevOps, I searched around a lot and I found a good thinking presented by Ben Kim, and I looked into it. I'd actually decided to follow it. It's called the 3 waves. And of course, you must make a business case and look at how much do we have to invest, and do a roadmap for the implementation steps. And this is summarized in this little image down here. So you can't rush into the DevOps technologies, because if you do that, the first steps will be very easy and it will go very, very quickly. You will run up to having something that you think it's a good DevOps environment, but the last steps might be very crucial if you haven't done the right thinking before you actually started. So the DevOps principle 1 is focusing on making the workflow from the business side up to the customer automated as much as possible. So it's complete the chain from the code out to the customer. Automate that part so you can actually do automatic builds, automatic deploys 2 different stages. And then you focus on feedback loops, because it's crucial that you get feedback. And normally you get feedback from log data from the customer to the operations and further down to development, and then finally back to business. So it's crucial to get that chain. First you automate in one direction, and then you go for opposite direction, meaning from the customer back down to the business. And it requires that you actually invest in quality logging. It means that you must really use the best tools to generate quality log data, because without any quality log data, you will be totally blind. So it's not just investing in DevOps, you must also focusing on investing in logging, and good logging, so you can get answers to the questions you need. And then the last step is everything is automated. So you have established a culture where you learn from each step from the start until you have deployed the code and the feedback loop. And if you have reached this step and if you are successful, releases and operations become boring. It means when you do release, the workload goes down. Normally in organizations where it doesn't work, the workload when they do release increases 3 to 5 times. So if releases are boring, you have completed the wave 3 successfully. And I've mainly been working in non-Microsoft environment the last years, but I've been looking into Azure. And when I looked into Azure now compared for 5 years ago, I got really amazed because Microsoft have done a really great job. So when I joined Strategate, I looked into how you can actually do things in Azure. Before I did everything in Amazon and we used the normal tools like Jenkins and so on. But here it's very easy to get a good start with the help from Azure DevOps. And I'm really impressed because it didn't took long to learn the basics and actually get the flow running. This is just something I think is funny, but we can skip that right now. So in wave 3, I tried to articulate why we must invest in DevOps, and especially from the top management team, because if you don't get a buy-in from them, you don't get any money. You can either recruit or you can't invest in the tools and so on. And you must really build a good business case. And what I've done is that I have assembled a team with different skill sets from both the business and the technology side, and even in some cases from the customer side, to build a cross-functional team, which mission is to sell in to the whole organization why and how we're going to invest in DevOps. So that's the first thing I've done. And the reason is easy, because if you do it correctly, you will gain a lot of time instead of spending time to analyze what is happening with the build of the test and doing manual things. You automate things, so you can invest in that time. In that way, you invest in time to you can add that time on development instead of focusing on how you build and deploy and test. So it's very important to have a cross-functional team. You can't, even if you are perfect technical people, you must be a cross-functional team. You can't do it on your own. So I use something called Kotter's 8 rules when I try to make a change in the company. You can look it up, but I think it has worked for me. So the cross-functional team, the main mission is to explain why we are going to invest in DevOps. And the second part is to collaborate across the whole organization and really foster buy-in and support. So everyone in the organization actually knows why we are investing in DevOps. So it should be clear for everyone. It should not just be a PowerPoint. It must be through communication with the whole organization that is affected. And of course, you will not succeed in all the steps, so you must also get buy-in for things will fail. But it's crucial to also set the standard if something fails. If the same error occurs multiple times when you're doing something wrong, but you will not succeed in all the steps directly, so you must accept failure in the beginning. So you must create a climate of change in the whole company, not just in the technology side, because the people who sits on the money, you must get a buy-in from them. So it's a lot about communication and being around in the organization. So that cross-functional team must be continuously communicating with the whole organization about why we are investing in DevOps. And then comes the part that everyone is happy. Everyone is very happy. Oh, we're going to invest in DevOps. This will be very easy. We understand why, we understand all the positive things about it. Until you come to another point, you must reorganize, you must change the whole organization, you must change your processes, you must change how you communicate, you must invest in new tools, and you have to do a lot of prioritization. Because if you have an hierarchical organization, it won't work with running DevOps, because everyone will be running in the same silo as they have done before. And you must also change the processes. The release process will not be the same, development process will not be the same, and so on. So you must really be aware of, you must have a rather flat organization, because you don't have us and them before. If you look at the operation team and the IT department, because they will be integrated with the development department. So it's about changing quite many bits, and when you reach this step, you must be really careful and really do it politically correctly. Otherwise, you will get resistance from many people in the organization. And you must also focus on educating everyone in, for example, now I'm focusing on Azure, Git, Azure DevOps tools, and you must do a lot about the prototyping so everyone knows how they use Git and how they use the Azure DevOps tools. Because if you ask, when I asked around in organization, do everyone know how to use Git? I always say, yeah, we know Git. And when you realize, when you start to work with Git, it's obvious that most people don't fully know how to use Git. Oh, they can commit code, yeah, but what happens when you do a rebase? What happens when you do a merge? What happens when you get the conflicts each and everywhere? So I think it's good to invest in actually teach everyone in the organization how you use Git and how you use the DevOps tools, and by doing a lot of prototyping, so they can get acquainted with the tools, because it's not 5 minutes to learn it. So it's good investment to educate everyone in the development organization, and even further outside the development organization. If you work as a product owner, if you work as a Scrum Master, I think it's good to know the basics about Git and the Azure DevOps tools, be involved in those prototypes. So that's what I've done, at least. And many people have gone through a lecture about Git. They said afterwards, this was very good, because now I actually understand what Git is. It's not just committing code and push it to a branch. It's much more complex, especially if you have a big organization like at Mercedes, 5,000 developers. That's something different compared to 5. So it's very important to learn how to use these tools. And of course, you must prioritize. And I always use Eisenhower's prioritization matrix. It's very simple. So you look at what is medium prioritized and easy, what is easy, what is difficult, and you focus on the impact. But remember, you must change the processes and organization in the company, otherwise you won't succeed. And some companies miss out one important thing. They don't have a defined branching strategy. If you don't have a branching strategy, developers don't know how to work with the code, and you get into mess. So it's not about any branching strategy that's better than anyone else. It's about choosing someone. And mainly you can use a mainline based or a feature based. If you use mainline based, then you use trunk based development or GitHub Flow. If you use a feature based, you use Git Flow. There are other branching strategies, for example, GitLab Flow and so on. But trunk based development, we used that at Click in the beginning, and Facebook also used it for many years. So it's just about defining, choose a branching strategy, and of course educate everyone what it actually means. And you must also think carefully through your repository structure and your project structure, because at one company, they created one repository for each component they built. And then they wanted to build one product out of that, and they hadn't really thought through how they actually structure the repositories. So I think it's good to invest in some thinking about how we're going to organize our repositories. Should we have one rule them all, or should we have separate, and how should they be interacted? Because this has impact in the task chain when you build pipelines. But I think it's good to invest in and look at what kind of structure we actually need. And it's always easy to move code from different repositories and merge it to another repositories, but that's something you must decide how you want to do it. And of course, define a version strategy. Maybe that's too basic, but it's good to have a defined version strategy. But I think it's important to start here before you actually go full Monty into actually building your pipelines and so on. And you should also think about quality metrics. In short, questions you want an answer to. What do you want to measure? So it could be very basic things about how fast do we move an epic, or how fast do we move a user story through from the time it's created until it's released. It can also be how long time does it take to build the code? Is there architecture issues you will discover and so on? But look at some basic metrics, what I call quality metrics. I think it's good to think that through. And of course, invest in quality logging and monitoring. When I looked at Azure, I've always been using the Elk stack, and it has been quite cumbersome to get that log data out and indexed and actually analyze it. But then I discovered Microsoft Azure Application Insights, and then things got very easy compared to using the Elk stack. But you must have a log standard. It means what fields do we add to the log, and how are the logs constituted. For example, if you have microservice, you must have a correlation ID. You can track everything, what is happening from the client down to the database repository. But Microsoft Azure Application Insights make that work quite easy compared to traditional way of solving it. But you must invest in that, because if you don't have good logging, you can't know what's actually going on in the system in the whole chain from the code is released, is committed until it's released in production. But that's how I've done. Of course, not all companies have the same requirements or do it in the same way, but I think it's good at least to have these bullet points to think, should we invest in quality logging? Should we define development or quality metrics and so on? Shouldn't we think through the branching strategy and so on? So it's more bullets, like a checklist I have. And when we come to wave 4, the first thing is to automate all builds. That's the first thing you do. And the second part is to automate pipelines. And that depends, of course, on your branching strategy, but that's actually automate everything from you do a build to release to the different environments and so on. That's the second step. And then you automate tests. And I think it's good to wait with the test, except from a unit test. I'm thinking about other types of tests, maybe component test, API test, integration test, volume test, scalability test, and so on. I think it's good to do them separate in the beginning, and then in step 4, integrate automated test in the pipelines. Because if you do too much at a time, you will have could be a little bit tricky to get it working. So first automate pipelines, and then add the automated test in the pipelines. Step 5, set the process for continuous delivery. So your release process or your development process should be focusing on reaching the step with continuous delivery. And if that works out fine, and you realize it's actually possible to do continuous deployment, of course you can do it. but you must set the process for release management so everyone knows what is happening when something is released into something is released and ready to be deployed in a production environment. Then we reach wave 5, and then you increase the feedback loops by investing in even more granular data, and you really do advanced data analytics, and that data is not something the operation teams just the operation team see. It's actually data that the development team sees. A company in Sweden is Axis Communication. All data, everything what's happening in each environment, it doesn't matter if it's productions, pre-prod, test environment or dev environment, all development teams have access to that data, so they can look at the analytics that someone has implemented, but they can also do their own analytics. For example, when we worked at Click, we focused on how many of our features is actually used. And when we used that information, we could see that 80% of the features were used, 20% of the features were never used. And we realized we were fixing bugs for those 20% of features that was almost not used. So it was not that clever investment, but we didn't know that until we got the analytics via data to look at. And then you can actually be, in the end, a data-driven organization from this aspect, from your release code and then the feedback loop back, so all the development teams have access to that data. And it's important that that data is not just visible for some parts, it should be visible for the whole development organization. And then you, of course, increase the measurement. You define more and more quality metrics and time to market metrics, the customer satisfaction metrics. You add the quality metrics when you reach this step. And which metrics you choose is up to each and every organization, what they think they benefit most from. But it was quite interesting to see which features were actually used and which features generated most error or warnings out of the production system, so on. So in some way, I think it's good to look deeper into the quality metrics. And when you reach this step, you should also intentionally try to break things to see what actually will happen. And that's quite funny, to destroy something intentionally. So see what will happen in the chain, what will happen in each and every step in the pipelines and so on. So focusing on crashing things to see what is actually going, because then you get a picture of how good is actually our implementation of DevOps. And of course, you stop doing things that actually don't add anything or work. And you should always ask yourself in this step, what could be automated even more? Because the more you automate, the more time you get for development, and the quicker you can release. For example, Access have a good metric. They say if a customer discovers a bug, they have an aim of, if that bug is discovered at 10 o'clock, all the customers should be patched at 12 o'clock the same day. That's a measure they put up. So what can we do to reach that? So then you really come into the fun things here when you reach wave 5. And of course, you must always make sure you still have buy-in for even investing more and recruiting more people to get this going. And then when you finally reach this step, you have actually built a full ecosystem, which with all the different stakeholders in the organization and all the different systems. And it's quite funny, interesting. It's really fun to see when it's actually working. So you have all the about requirements, build system, test system, code review system, issue tracking. All this is integrated, and this is actually possible in a good way when you use Azure. And then you come to maybe the most challenging step, and that is you should never be satisfied you should always try to be better and better and better. It means you should always be focusing on continuously improve. But most companies, or many companies, I don't say most, but many companies, they don't go through this step. They sit and are happy what they actually have done. But this is not the way you can actually improve more and get more competitive as a company. Because what we have done in some companies, every software generates bugs, and sometimes you generate a lot of bugs. So in some company I worked, we have 176,000 bugs, and it's not that easy to prioritize them to fix the right bugs. So a young guy, he did his thesis. So we asked him to build a system that actually could import all the data from Jira in this case, and all the bugs, data about bugs in Jira, and use supported vector machine and build clusters of the different bugs, and based on that recommend a prioritization of bugs, which mean which bugs should we focus on, because it's not that easy to prioritize those many bugs for a human. So he built a tool that we actually used, and it worked out very well, because at that company we didn't have 176,000 bugs, but we have 70,600-ish bugs. And the vice president said, well, we must bring down the number of bugs. Let's see if this tool actually do the work. And we reduced the bugs in 5 months from 70,000 to 450. So it actually went quite well. But I also know companies I worked in that they have looked into using artificial intelligence in test automation based on deep neural networks, decision tree learning, and so on. And there are actually tools in the market that called application tools, Functionize, Mabel, Partasoft, SO, Test AI, Testim.io, and it's challenging, but it's also fun for development teams to get to try out this different type of tools. So this phase is about getting more and more, doing more and more complex things, because you have some stable foundation. So now you want to become even better. So let's look at. So it's interesting to look at how you can automate bug prioritization and use artificial intelligence in test automation. So you should never be satisfied. You should all the time focus on getting better and better, improve, because then it's also fun for the development teams, and the company will benefit from it. And Gartner also said that it's becoming more and more common that companies invest in automated test automation based on artificial intelligence. So it's not a hype, but it's something that's actually going on in the market. So this is just a short introduction. I talked with Emma about if I can compile some PDF of this presentation if anyone wants to look into it. I don't know if anyone has any questions right now.
So we've had a few questions come through, Lars, that maybe
okay.
we can get around to. So first question from Richard was, would that cross-functional team be a sub-team of the Cloud Center of Excellence?
The cross-functional team I used was architects, developers, and people from operation and from customer support. And that's how I established that cross-functional team. Maybe I didn't answer his question, but it's good to have some different skill set in these teams, because some parts of it is organizational, some parts is processes, and some parts is technical. And in some cases, you must know also what the reality out at the customer, and often customer support and operation knows those areas. But I don't know if I answer the question in a good way, Emma.
No problem, that's fine. If Richard, if you do want to add on to that, feel free to in the chat. The next question that came through, so when you mention metrics and logs, is this really a reference to observability and having a good observability solution in place?
Yeah, it is. It's crucial, because if you don't have good log data, you're actually blind. And especially if you invest in architecture that's actually based on microservices, then you will get into trouble if you don't have good observability in your system, so you actually know what is going on. I don't know if that's a satisfying answer, but it's the yes to the question.
Great, thanks, Lars. And the final question that's come through for now, where does chaos engineering fit into the DevOps process?
Chaos engineering. Oh, it will be a chaos in the beginning, but I've not looked at it from a chaos engineering perspective, actually. But you will, in the beginning, you will run into some kind of chaos, but I don't know directly the link between chaos engineering and DevOps right now. Could he elaborate the question a little bit, Emma?
Yeah, Richard, if you'd like to. Oh, okay, so chaos engineering, like solutions from Gremlin.
From Gremlin?
Yes, so gremlin.com.
I'm sorry, I've not looked at, but I can look into it and maybe get a better answer. But I haven't looked at that gremlin.com, but I can do it. Maybe I can give a better answer after I have looked into that site. Is that okay if I gremlin.com?
Yeah, it's just in the chat there. Richard is posted
Okay.
it.
So it's in the chat. Ska vi se. Okay, there it is. Yeah. But I can check out that. Can I look it out later? And because I'm not. Is it okay to look it up later?
Yeah,
Richard?
absolutely. And maybe Lars, if you're able to share some contact information, Richard could follow up with you after today's session.
Okay. Yeah. I can send him my mail. So
great. Okay.
Okay. Yep. Okay. I will connect with him. Yep.
Great. I think we have another question that's coming
Someone
through.
is typing.
We do still have quite a few minutes left, so if there are any more questions, comments or feedback as well from today, feel free to share that in the chat too.
Yeah.
Whilst we still have some time.
But should I continue with the second part, or?
Yeah, absolutely, and we can get around to the rest of the questions after.
Yeah, okay. I should just find my presentation here. Okay. So I will go back. I will start to look into, I will demonstrate about how you can actually use a tool called Cake and generate builds and generate pipelines out in Azure with using Cake. So Cake is a tool which makes it possible to use to write C# code and generate builds. And this is what I would do. So this tool here, I will share my screen here. I hope I can still see it. So what I will do here is I will automate the clean, the package restore, the compile, the analyze, the unit test, the test coverage, and generate the package and publish it. So that's what I would going to do here in that session about writing C# code with the assistance from Cake. So I don't want I don't think we should invest more time to look into the slides about cake. So it's okay. So I can just demonstrate what I've done with cake. Is there anyone who is having big troubles to look what I'm presenting on the screen here? Or is it possible to see it? What do you say, Emma? Is it possible to see?
Yeah, we can see that. It looks fine.
Yeah, okay. So I created a simple .NET 3.1 web API, and I thought about writing C# code to generate all the steps about the build steps here and send it to Azure and generate the pipeline. So the good part about this tool Cake, you can do it even more complex with cake frosting, but it's good to start with cake. You can do very much about cake. If you go into cake frosting, you can do it in fully object orientated, but I think it's good to at least start with cake. You can come quite far just with using cake. So what cake is normally, you have in the top section, you have a number of variables and settings you want to do about what you're actually going to release and where you're going to release it. I would release this to a dev environment. So I have some targets and some, like you always have in C#, some variables I want to reuse. So you put them at the top, and maybe you can add some NuGet packages you want to add to do extended things here, but I haven't added that much. So normally you do a class that summarizes the project, and then you do a setup that explains which is the project and where are the files and what kind of things are you actually going to build. The second part is that you maybe have some information about the task you're going to run. The good part here is that you can debug this code, so you can run the whole pipeline locally before you publish it to Azure, and you save quite a lot of time, because here I can run it both in debug mode, so I can set breakpoints and so on. I'm using Visual Studio Code, so I added Cake there. So for example, if I want to run this task here, so it's important when you do this in C# like you do it in Azure with YAML files, it's important to do the task in the right order. So for example, I can click here on debug task and show. So now I have done a breakpoint, I can look further and then I can continue to run it. So the first part you always do is a restore after you have done a clean. So in the beginning you do a clean, you remove everything from a project, so you start from scratch when you do the build, and then you just take the next step, and it's dependent on restore clean. You do a restore and it's dependent on clean, so you must define the dependency chain between the different tasks you're running. So here I just call .NET Core restore and the solution file. I just do a .NET restore on the solution file. So after clean, I do a restore, and then I can move on. I do the actual build, and of course you must keep track on what is dependent on build is dependent on clean, and it's dependent on restore. And then the built-in function here in Cage, you just use .NET Core build. You point out the solution file and maybe some additional parameters, and then you actually start the build. And then you run your unit tests in this case, and it's dependent on build. So I pick up all the test projects here, and I generate, even in this case, a test result file. And I generate all the tests, so it will run all the unit tests. And then I have to package it, and package is dependent on test. So I generate NuGet packages here, and I use a built-in function in Cake called .NET Core Pack. I don't go into data, so I just look into a higher level here. If I want to, I can publish it directly on Azure and see if it's running on Azure pipeline. I don't do this in this little prototype here, but I built the packages. Now I have to publish the packages. And I called, so I just do a publish of the packages here. I just copy the files to a specific directory. And then I finally do the task default. Up here, I had the target default. So that's the final task it will run here. So I can run this task here, and I can do it, for example, go out here and write .NET Cake. So I build everything and generate the pipeline locally, which means I save a lot of time. It's much quicker compared to doing a commit and do something and wait for the things that's going on in Azure. So you can do everything here and you can debug it. So now it's doing something here. I just test that my code is actually working. And you add in Azure DevOps, you add an extension called Cake. And in this case, you can take this cake.build file. I have a cake here, cake.build file. So I can put that file in my repository and point it out and use it with the help of the Cake extension out in Azure. So I will start my little simple project here and just do a change. So I just added some lines of text, and then I do a git, and then I text info. So I commit it locally to my local repository, and after that I just go into the tool and do a git push. It means it will push all the changes from my local repository up to my Azure repository. And when I come in here, something will happen because this is my build pipeline. And if I do a refresh here, you can see, yeah, it's actually autumn. So immediately when I checked in the code, it started to build the code. And you can follow the steps here, what's actually going on. I hope people can see what I'm showing on the screen here. So I can see here, I will initialize the job. So all the different steps that I developed before will actually kick off here. And it will not take that much time. It will take 1.5 minutes. So just by writing C# code, and I think it's much easier to write C# code and control what you're actually doing compared to editing big YAML files up in Azure. So now it will add .NET Core and so on, everything that I was running locally. And it's good also that you can debug and run everything here in Visual Studio Code. So you download Visual Studio Code and you add Cake as an extension here as NuGet patches in Visual Studio Code, and then you can start to write your cake.build file. And now it's come to Cake. And I leave this area now because now comes the interesting part here. We have a release. So I've configured simple. So if you look at the edit here, so immediately when the build has succeeded, it will pick up the artifacts and deploy it directly to the development environment, all the changes I've done. And everything here is totally automated. It's not done yet, the build. It will but you will see it will change here. I just look at the status. So this is some way to can actually automate the whole chain from the code until you do a build and you publish it in a development environment. Let's see what it's actually doing here. Now it does the publish and so on. But it will not so. Now it's done. And if we look here at releases, it should, let's see when it kicks off here. It's not, is it already done? Yeah, it's already, no, it's already done, I think. So it generates a released over code in a development environment. It's a little bit slow. My internet, yeah, at least it succeeded at least. 11:59. So, or it maybe didn't. Now we see that it's actually running. I was a little bit quick. So now it's automatically deploying the code. Here you can follow the process. It's downloading your artifacts. It sets up Azure App Service in the development environment. And it won't take that long time, but maybe it will take a couple of minutes here, but I don't know. So it will soon be done. So these things here could then be shown in the Azure portal when it's done. So it succeeded now. So here I have in Azure DevOps, I configured based on what I did in the build stage, I configured Azure web app that's automatically updated based on what's happening here in the Azure pipeline. So what I did was write the C# code using Cake to generate the whole pipeline, to generate the whole build. And then I developed a release pipeline that took that code when it was done and publish it on a development environment with an Azure App Service. So I really like this because it gives you better control compared to just editing YAML files. It's not wrong to use YAML files, but I think easier to say you save time to actually be able to do all the things locally before you actually instead of sitting and waiting on what is going on in Azure, because this is just a small code example, but in some cases the build can take many minutes to complete, and you save time to be able to debug and control it locally. So this is what I've done here. So I don't know if you're looked into Cake before, because I didn't know what Cake was for maybe 2 weeks ago, but I thought it was fun to explore it. So I think you should focus on, I think you will gain time if you're focusing on tools like Cake or Cake frosting to automate, to generate the pipelines instead of doing everything in YAML, because the big advantage is you can debug it and you can run it locally before you actually kick off everything out in Azure DevOps. So I don't know if I have it. I have already used too many minutes, Emma, or
all good, no worries, Lars. We've just had a couple of comments come through. No questions as of yet. But again, we do still have a few minutes. If there are any final questions, then please do send them through.
There's a lot of messages.
So if you scroll down towards the end, we've answered these questions that came through from Richard.
Would that cross-functional team be a sub-team of a cloud center of excellence? Yeah, that's most likely. you mentioned metrics and logs. Is it really a reference to observability and having a good observability solution in place? Yeah, because I think if you don't have log data, you don't have any observability at all, because you just have log data and you can't get any use of it. So it's a good investment to really generate the log standard, how you log things and how you actually so you have all the data for actually doing the analytics. But it depends on what you have to measure. But I think at least you can start with 5 fields, but in the end, you need more fields so that you can do real analytics of the log data. Is there chaos in Gremlin? Is there any other session of this presentation, someone asked? I don't know. And then someone added, okay, so there's a lot of things added here. Have I missed some comments, or is there anything that someone don't think I've tried to answer, or have I missed anything? But I think Thiago Lima, he added some good things here about chaos engineering as a mixture, continuous control, continuous feedback, continuous improvement. Yeah. Is there anything you think I missed, Emma?
I don't think so, Lars. I think you've covered quite a lot in the last hour. So thank you so much. It's been a real pleasure to have you deliver to our Reactor community. Again, if there are any final questions, feel free to send them through now before we wrap up. But if not, Lars, are we able to make this PowerPoint available at all? Maybe edit it, we could share as a PDF. And also if people want to contact you afterwards for any questions, is LinkedIn the best way to do that?
Yeah, or is it? I don't know, but if it's common, but I can add by mail here in the chat if that's okay.
If you're happy to do that.
Because this topic is quite big, so it's not that easy to cover. So I just try to do it on a higher level because there's so many things to talk about. So, but I just wanted to show not just a presentation. I want to show something that actually running up in Azure.
I do see a question that's come through from Praveen. How will Cake work in the case of deployment to Azure Kubernetes service?
You can add that support. So you can generate Docker containers and you can integrate it, because Kubernetes is how you maintain all the Docker packages. So you can add Docker containers. But I know that I saw some videos about how you actually use Cake to use Azure Kubernetes services. So it's possible. I didn't do it in this. I just do the traditional way here. But I know it's possible. Should I send the presentation to you? Should I make a PDF of the presentation and send it directly in the chat, or?
So if you want to send me the PDF, I will and then share it to everyone who's joined today. So just look out for a message on Meetup, and that's where I'll share the link to the deck once it's available.
Should I send it by mail to you then?
Yeah, Lars, you can send it to me right now. Great. I think we're just about on time now. So thanks again, everyone, for joining us. I will stop recording.